Hello, beautiful people. Welcome to 1.6, multiplying and dividing real numbers. Our SWABAT is to find products and quotients of real numbers. So, vocabulary, multiplicative inverse. Given a non-zero rational number, a over b, the multiplicative inverse, also known as the reciprocal, is b over a. The product of a non-zero number and its reciprocal, also known as multiplicative inverse, is 1. So if this is a over b, and its multiplicative inverse or reciprocal is b over a, they're saying that if you multiply them, you should get 1. Well, it seems to work to me. I'm a cross canceller. So if it's up top and on the bottom, I can cancel it. These become 1s, and I can cancel here as well. So all I have left is 1. Alright, so some rules for multiplying and dividing real numbers. If the signs are the same, so same signs, the result is going to be positive. If the signs are different, the result is going to be negative. I don't know if you've heard it, but they say opposites attract, but likes stay together. I don't know if it's true or not. So this is life. I want you to write this down. Some people will make it into a face or something. I'm not that artistic, so I'm going to leave it like that. But I want to let you know that this pretty much summarizes that. So if I have a negative times a positive, the result is negative. What's left? If I have this positive times a negative, negative. What's a negative times a negative? Positive. It's the cover-up method. So you're going to cover up what you're multiplying, and there's a result. The sign that's left is the sign of your answer. Positive, negative, the result is negative. All right, let's see this in action. Find each product, simplify if necessary. So, first of all, I'm going to multiply 5 times 7, and I get 35. And then I have a negative times a negative, which is positive, so this is going to be a positive 35. Final answer. For the next one, I have negative 0.6 times 0.6, negative, because it's squared, it's the same thing times itself, if that bothers you. Oh, it's bothering me. 0.6, negative 0.6. 0.6 times 0.6 would be 36, because 6 times 6, and there's 2 numbers after the decimal point, so I'm going to move it over twice. And then I have a negative times a negative, which would be positive. So my answer is positive 0.36. I love it. Next one, I have 2 over 5 times 5 over 8. I have this 5 and this 5, so I'm going to cancel those out. And then what number goes into 2 and 8? 2. 2 goes into 2 one time, and 2 goes into 8 4 times. So I have 1 times 1 is 1 up top. And then this is just a 1 times 4 is 4 in the denominator. And then I have a negative times a negative, which is also positive. Cool. Now a little bit of a review of our radicals. So square roots. The only difference between these and what we've done in previous lessons is now you have the sign out front. And whatever this sign is, we're going to keep it. If it's plus minus, I want the positive and negative of the square root of 1.44. Now recall, 144 is a perfect square. It's 12. The square root of it is 12. Now I have 2 numbers after the decimal point, so I'm going to cut those in half. And so I need to move it over 1 time. So my answer is positive negative 1.2. I'm going to box that. Makes it feel a little bit more official. If it's negative, my answer is negative. Negative what? Well, I want the square root of 16 over the square root of 49. They're both perfect squares, which is great. Square root of 16 is 4. Square root of 49, 7. You like it? I love it. Square root of 100 is 10. Square root of 121 is 11. That's a horrible box. My bad. And it's positive because they didn't have a sign in front. All right, division, again, follows the same rules. So if you'd like to, you can go ahead and press pause and do these without me and then just check your answers in a minute. But I will tell you 51 divided by 3 is 17. And then a negative divided by, oh, can't see me. Negative divided by a positive, the result is negative. So negative 17 for that one. Negative 93 divided by negative 3, trust my math, is 31. So I have a negative divided by a negative, which is positive. Are you sure? Yeah, I'm positive. And then I have negative 8.1 divided by 3, and that is a number, so I think it's 27, and then I'm with a decimal point there. Don't believe me? Use your calculator. I won't be offended, but I'm right. It's negative 2.7. Why is it negative for this one? Because I'm dividing a negative divided by a positive, which leaves me with a negative. Do you have to use this? No. But I have seen people, even in Algebra 2, that still use it because it's kind of helpful. Kind of helps you not get those signs mixed up. All right, beautiful people, we are almost at the end of this one already. Find the values of the expression a divided by b. So I'm looking at a divided by b for the given values of a and b. So instead of a, I'm going to write negative 5 over 6 divided by, and instead of b, I'm going to write 1/2. Now for division of fractions, I'm going to remember that I have to multiply by the reciprocal, or multiplicative inverse. So that's 2 over 1. Me, being the cross counselor that I am, I see that 2 and 6 have a 2 in common. 2 goes into 2 one time, 2 goes into 6 3 times. 5 times 1 is 5. 3 times 1 is 3. And I have a negative times a positive. Negative times a positive leaves me with a negative number. Negative 5 over 3. And again, I'm fine with improper fractions until we have to graph them. But otherwise, as long as it's reduced, this is the perfect answer for me. All right, so your question following this video, because this was a short one, is what can a person do to ensure that they don't get the rules for addition and subtraction mixed up with the rules for multiplying and subtraction? So I'm sorry, multiplying and dividing, like I just did. Don't get those mixed up. Give me one good solid tip that you would pay forward to somebody else for knowing the difference of these two rules. All right, beautiful people, thank you so much for joining me, and have a delightful day. Bye-bye.